let's see. Okay, perfect. A year ago, it's like we are almost an anniversary of Russia's invasion to Ukraine, and we all see the devastations of what's happening. But for people in Russia, things are different, and the reason behind this is that Russian users and public in Russia found themselves in a very extraordinary situation where their government started to aggressively block the content, not only news and circumvention tools, but also further to prevent the free flow of information about the war in Ukraine. But also, we saw the West, thousands of or hundreds of websites in solidarity with Ukraine started blocking Russian users. We also saw, for example, TikTok, which blocked Russian users from the rest of the world. So if you were a TikTok user, you couldn't actually send videos to Russian users at the time where the war was starting and becoming worse. And that helped Putin and Russian government to actually perpetuate the false reasons behind Russia's war with Ukraine. Okay. We also have seen Mahsa Amini's murder in Iran and what followed months of demonstrations from the public and their desperations of getting the images out for the West to actually defend the rights of what's happening inside. When these kind of events happen, there is very important to ask questions as a researcher who work in the field of internet censorship. Like, what is being blocked at the time? What censorship circumvention tool is working? How governments are technically blocking these websites and the content and circumvention tool specifically. And more, thinking a little bit out loud by the data we're providing on what strategies Russian government had in mind and what does that mean for internet freedom and the brink of authoritarian governments that is going to be following the footsteps of Russia. Detecting and defending adversarial network is a really challenging problem because we're dealing with lots of stakeholders. Internet is a heterogeneous network, and especially in the case of Russia, there's thousands of ISP, each of them run by oligarchs in the private sector, and they all equipped with commodity DPIs. At the same time, Russian government have been working on building their homegrown DPI called TSPU devices and gave them to their ISPs as a black box and a tutorial so that they basically have a centralized way of controlling information on top of what the ISP is already blocking. Having that in mind, studying and collecting censorship data is also very risky. At this moment, for Russian users to collect internet censorship data, they might end up to jail, 15 years to jail. So the fine for participating in this kind of investigation for the activists on the ground is really high. So my research is all about building techniques and systems to protect users from adversarial networks. And I'm not just talking about censorship, although I'm more known about censorship studies that I've done, but we are talking a lot about keeping track of any violations, be it integrity, confidentiality, and availability violations. And we're talking a lot about a lot of who's. It's not just the government messing with users' traffic. We have server-side, clouds, embargo rules by the West. We have a device manufacturer, and so on and so forth. And there are so many ways that they can mess up with the user traffic. It's not just blocking we all think about. It's about targeted surveillance, content removal, and shaping what people can see, and so on. In this talk, I'm going to dedicate the first part of the talk to how we built SensaPlanet and what type of problems we worked on. And then a second part of the talk, I pivot about to how we can actually safeguard consumer VPN ecosystem. Of course, I couldn't have done this work without my lab and the students who have dedicated years of their work to pursue this research project and publish them. First part of the talk, detecting censorship with side channels. Years ago, almost a decade ago, when Arab Spring happened, the state of the art of measuring censorship was putting instrumentation on a client or server side to collect the data. What I mean by that is we would ask volunteers in the regions to run a software or give them a Raspberry Pi, and they would connect it to the internet, and through that we had collected the regular data. But that approach is not scalable. It doesn't cover all the networks in all the countries we were curious about. More importantly, it couldn't lead to a continuous data collection because users have to be motivated to keep the measurements running. And you would have a good data at the time of a political unrest, but then the data would not come. So analyzing and investigating that data as a time series to see the trends of censorship was not doable. More importantly, asking volunteers and asking them to give us a consent to do such a study was also risky. With all these challenges, the state of internet censorship 10 years ago was way behind. So I started thinking about this problem differently. Specifically, the goal was, for me, being from Middle East, where most of the censorship is going on these days, how we can collect this data without asking volunteers in a region. There should be a way that a measurement machine in the United States, let's say, can capture what's going on between client and server. Is it? And I remember very specifically that many people I consulted with them told me this is a dissertation that would fail. But there is something very visible when you internet-wide scan the internet. You can see there are lots of machines that follow protocols and connected to the internet. They are machines that you send them a SYN packet and they respond back. They are DNS resolver that you can resolve, open DNS resolver that you can, from University of Michigan, you can scan and resolve DNS queries from them, and billions of web servers, and so on. So the question started to change. How can we leverage these vantage points that are already connected to internet to be able to collect censorship data from them? And over the past decade, I have dedicated a big chunk of my research to build this avenue of research, which is side channels for remotely collecting censorship data. We have techniques in place to measure TCP/IP disconnectivity. We have ways to collect data about DNS manipulations and application layer disruption. And this is basically, these side channels basically cover most common ways that the governments or censors disrupt user traffic at the moment. And for this talk, I'm going to just go over one of this technique and explain what I mean by side channel and remote measurement, and we go from there what we built on top of it. The first technique was spooky scan. Actually, this paper is very dear to me because usually people don't find it. Because I was Iranian, I didn't want to use censorship word in my publication, or before I feel a little bit more confident about I can stay in US. So we called it intentional packet drop. And we didn't use a good branding like a spooky scan at the time. So that the paper detecting intentional packet drops on internet via TCP/IP is actually the paper that the whole sensor planet is based on. So what is this technique is about? Let me go through some basic TCP protocol details that I'm using for the side channel. The first part, sorry, I know the room knows this, but just a refresher. There is a TCP handshake. We send a SYN. The server sends you a SYN-ACK. You send an ACK. This handshake, in the IP headers of the packets that go back and forth, there is a field called identification. It is being used for fragmentation reason. And part of the protocol said if you send a SYN-ACK to a machine with the port status being open or closed, it's going to send you a reset. So why are you sending me out of order SYN-ACK? And another part, because TCP is reliable, if you send a SYN packet to open port, it's going to send you a SYN-ACK. And if you don't respond anything, it's going to repeat and retransmit that based on operating system, it's 3 to 5 times. So for the spooky scan to work, remember, I want to be able to see whether a machine in middle of Iran can talk to a server in Sweden, let's say, and I don't want to be in the path. So that's the goal. So I have to find a client machine that maintain a global IP ID variable, meaning that whenever that machine create a packet and send it, disregards of to the destination, that counter is going to be +1. So if I look at the traffic of that machine, let's say I send a SYN-ACK and it gives me a reset, over time I can learn the noise of that machine, how many traffic it generated per second. It's a shared resource, basically. And then the server should have an open port, like port 80, let's say, or 443, and retransmit SYN-ACK, which is obviously there. One key constraint that I have is the measurement machine should be able to do spoofing, meaning that I should be able to send a packet with source IP different than mine. Usually that is hard to get. You have to talk to your upstreams and deal with your internet providers to let you be able to spoof packet, but in any university I have managed to get that permission. So spooky scan work as follows. I have a client machine that follow a global IP ID in China. I have a Tor bridge that is in Sweden, and I'm sitting in University of Michigan. The first SYN-ACK I sent, when I get a reset, it disclosed to me the IP ID value is 7,000 right now. The next step, I send a spoof SYN packet to the server using the client IP. As a result, the SYN-ACK will be going to the original clients, and the client will send us reset back, making the IP ID to increment by 1. So the next time I query IP ID, I will see a 2, meaning that in between, the 2 talked. And of course, if I query IP ID again, I won't see any changes except the effect of my own request. But imagine the case where the traffic between server is not going to go to the client. In that case, client won't get any packet from server, so IP ID only going to change by my own traffic. Now, imagine that another case where the SYN-ACK gets to the client initiate a reset, but the reset doesn't get to the server, so it's going to retransmit IP ID, retransmit reset multiple times. So I see a jump in IP ID. So putting these 3 together, we have server to client being blocked, 1-1, 2-1, 2-2, 3 different cases for 3 different ways that the situation would be between client and server. Of course, you might say that this is a noiseless model. This is where the client at a time talks to so many other machines. Of course, we deal with that by sending, amplifying the signal. Instead of sending 1 spoof SYN, let's say 5. And because there are ways that the packets can get dropped, so you can repeat, you should repeat the measurements, so we can deal with that as well. So here are some of the results, and of course a little bit of cleaner results for the making a point. We had a probing method where we sent 3 SYNAC to the client, and we, for another 3 seconds, for every second, we spoofed 5 SYNAC, 5 scene to the server. You can see that in the case where we had a Tor relay in Sweden and a client in China, basically we saw a server to client block. In the case that it was no censorship, you could just see we have only a jump of 5. And in the third case, you see the effect of retransmissions. This is a client that was in Azerbaijan at the time. And so then the question becomes, how do we detect this? Autoregressive moving average is one way, and we apply it, and it works. And that was the first technique we came up. So you can remotely detect whether a Tor client, Tor bridges is being blocked by different clients around the world without even being in between. That's the side channels I was talking about. When we did the spooky scan, one thing became clear to me, and that was if we want to scale this up, if we want to run this for all the clients I can find on the internet, towards a lot of server, we have to respect the noise of a machine. For example, I cannot collect the same 30 probing methods when there is a machine with a lot of noise and there is a machine with none. So you have to build a system that is robust to the noise that is out there. So we came up with a follow-up work called Augur, that its goal was, instead of using ARMA, which is required to see a moving average, like a window of average being changed, it basically uses a sequential hypothesis testing. It spoofs packets until it is confident that it can detect the case. So the basic technique was like, okay, now that we have this remote technique, how we collect the data for a global observatory that we wanted to build at the time. Well, let's scan the whole internet, see how many global IP-ID machines we can find, how many servers are we interested. Let's make sure these clients and these servers follow basic checks. And after that, schedule and use the whatever statistical technique we are interested, be it ARMA or be it a sequential hypothesis testing. And there you go. We had the technique. When you look up and when you test, there are 22 million global IP-ID machines out there. And contrary to what even I anticipated 10 years ago or 8 years ago, the number of global IP-ID machines haven't decreased that much. We're still having enough of vantage points that or Windows XP or some version of FreeBSD that we can use to collect the data. So the coverage is good. When you're dealing with running measurements remotely, continuity of the data is within your hands because it's how much you run the measurement. You can decide and schedule the measurements being run. But when it comes to ethics, of course, at this moment, we are collecting the data without a need for a consent from volunteers and people risking talking to the outside researchers to facilitate collection of data against their government. But still, as you can see, this approach is not a non-zero risk. There is still some SYNAC and resets being communicated between client and server without their knowledge. So how can you reduce this risk? Well, let's use infrastructure machine. Let's go to the core routers being operated by ISPs themselves. Of course, it heavily affects the number of vantage points we can find from 22 million to 53,000, but that's good. And that's the sacrifice we can accept to guarantee ethics. Okay, so after Spooky Scan and Augur, we continued building the arsenals of the remote measurements that we could have. We came up with satellite, QAC, hyper-QAC, each of them covering different protocols and the disruptions that happens. But there is key thing here. This is just raw disruption that we measure. We measure only whether a client can talk to a server on that specific protocol and if it's disrupted or not. That's not censorship. It's if you collect the data over time and see the changes or put them in a space and you suddenly see, okay, this behavior is being observed in a whole network, which is a residential network in this big country. At the same time, there is unrest happening. Yes. So from the raw data to the insight and the label censorship happen, there are so much more steps that needs to be taken. And for that reason, we actually built Sensor Planet Observatory, which synchronized collection of data from all these remote measurement techniques, and do that in a harmony, in a way that the output is predictable, the time of the measurement, the web size we are collecting towards, and so on and so forth. So we put a lot of effort to orchestrating this measurement properly. And then now that we have the data, we started to think about what are the data science techniques that can be actually helping us to get to actionable insight. And the last step of Sensor Planet is we collect this data, we make them we come up with a way of detecting something like, okay, it's close to censorship, but until the data is not used, the whole effort is pointless. So now that we have been doing, we have to figure out what is the best way for facilitating data use and making it available. From the launch of 2018, the launch of Sensor Planet, till now, we have more than 94 billion data points. It's not 49, actually. I have dyslexia, so it's not 49, it's 94, and even more now. But we have been collecting so much data points on the censorship globally from more than 100,000 vantage points in almost all the countries, and towards thousands of popular domain and sensitive domain that was shared with us through expert knowledge. Now that we have the raw data, we have to think about building the art of censorship data analysis. And that's at a scale is a little bit harder than at first even us anticipated. There were so many anomalies that show up. Like, for example, suddenly a CDN start sending access denied messages to our queries, which is very, very similar to what the governments would do when they want to block the access. Our measurement sometimes, if not properly rate limited, might get bot detection or the IP, the client IP we use might be actually end up with having a bot detection block page and so on. So we have to figure out a way to deal with all these anomalies. We have to think about, of course, our data is continuous, but there are vantage point disappearing and coming back. So it's not as smooth of a time series analysis that you would imagine. And there are so many different types of errors that kick in. There are not one recipe for censorship. Some governments just block the traffic, just drop everything, some reset, some block page, some, you name it. How we want to deal with all of this is its own journey. But at first, we knew the first thing we have to do is we have to find a way for synthesizing the data collected from different censorship techniques or side channels that we have. And we came up with the universal data scheme. We recognize that all the vantage points we have are not equally valuable. If you have a vantage point in a residential network, it's way more important than a vantage point in a cloud that we selected by accident. So, and also if we have almost 100 vantage points in one network and only another one in other network, their value is different. So we have to deal with how you want to interpret this. And we sometimes deal with outlier vantage point, a vantage point that show up and have a burst of traffic and then disappears. After we deal with all of this, then we have to do trend analysis. Like, okay, now that the time series that we have some sanitization steps that it goes, then let's look into what we see. For example, we have observed the SNI blocking has been on the rise from 2018 till now. We see a really statistically significant disruption towards SNI. And that can be explained by more and more websites are moving to HTTPS. But when it comes to disseminating and getting the data be usable, I learned a very big lesson, which is you cannot go with what you think is the right thing. We actually sat down at first informally with data users, experts who have looked at the event, censorship event, and actually used the data, and asked them in the first round, what's wrong with our data? And they gave us so much good input. So we applied scientific methods like qualitative and quantitative survey to actually figure out what is the best way to build the dashboard for censorship. And this was on. If you would ask me, I wouldn't know that from a research project there is going to be so many fruits that you can write a research paper on it. And more importantly, I want to say this because it's when I was starting my assistant professorship, building an observatory and functioning it and collecting the data and deal with data users and so on was a lot of time sink. But we as a lab decided that we really like it. We get a kick out of talking to the activists, talking to the NGOs, building our relationship. So we did it for the fun part of it and for the impact that we could see and the friendship we established. But later we noticed that, no, it actually ended up paying off really well. We're sitting on a data no one has. We're working on things that no one else can actually do. And when it comes to a worldwide event about a government going after a very unique way of blocking censorship, activists reach out to us to do that. So we end up doing a lot of rapid responses to investigate the governments and get so much publicity out of that for the lab. So one of them, like just give you an example, our collaborator in Kazakhstan sent us a text in Friday, literally told us government is sending text messages to their whole town, telling them how they can reach to the popular social media in the days following. The text had a link with a tutorial how they could add a root certificate to their browsers so that the government could man in the middle the whole traffic. That was done at a scale unprecedentedly. And Chrome and Mozilla and other browsers didn't even know this is happening until we did our investigation. We collected data from hundreds of measurements, vantage point in Kazakhstan, showing this is not just the one text, it actually covers a lot of network, and this is a policy by the government, and then get everybody rallied to actually take a stand on this. And there were so many papers we end up publishing on the topic of censorship and around the topic of internet freedom issues. So something that I think some lesson learned for me was it was very important to choose a topic you're passionate about, you feel it is important, and do the right thing. So in each of these steps we took, we could take a shortcut or we could stop going further, but we really wanted the impact to come. And we were lucky that through this path, we ended up with more research paper. The more door we opened, the more we found, okay, no one had looked into this, let's write a paper on this. But that wasn't our goal. The goal was like, let's fix this thing. And I think that's the biggest thing. I think I made a peace with myself 2 years in when my first NSF career got rejected, that if I can make this work, I will be happy even if I don't stay in academia. And that assurance in my head helped me to make a right decision at the right time and not take shortcuts that usually people do. And I hope more people do that, but I hope more people also have a support system if things doesn't work to help them not fail. Anyway, when we were doing all this, I'm not going in, but for those of you who are interested, we have done a lot of work in understanding actual specific technology that is doing the censorship. Like, for example, that block box, that the TSPU boxes that Russian governments give their ISPs. We did a study on that, how Great Firewall of China actually blocks the convention tools and so on and so forth. So I have a knack for actually going head to head and understand that device and analyze that. Okay. But bringing transparency to censorship and detecting censorship is one part, but how do users defend themselves against adversarial networks? It seems VPN has been the solution. So around the time, for as long as I know, for a person who works in security and privacy, especially talking to NGOs, you were always asked, hey, what VPN should I use? And what's your threat model? I don't know, I just want to feel safe and secure about all this. So the topic of VPN keep coming back. And this is not just me saying that people are more and more interested in using VPN. Research has shown that over the years, the VPN industry has become $1 billion industry. The number of VPN providers that advertise and market themselves to users over YouTube and other social media has been increasingly more and more over years. But the problem with this VPN ecosystem is it's very, very lax and unregulated. And many users are being misled to what VPN does through marketing, through bad marketing. So we were in a talk at IMC 2017 or 18 where they looked into the VPN ecosystem. They basically had their student, like a couple of students downloaded a popular VPN and manually went through them and analyzed how awful the VPN ecosystem is. And that work was really like where we found that there is a potential here beyond this one paper. So we looked at the related work, who is working on VPN, how's VPN being investigated, VPN ecosystem is being investigated, and we didn't find much. There was a couple of papers, honestly. This was shocking to me. And from one paper to another, heuristics and the test was so different, so you couldn't see patterns as easily. So there were problems like rigor, scale, and automation. You needed students to do a lot of labors to do one study on a VPN, and the churn in a VPN is so high, they come and go so fast. So how can we do a better job in keep an eye on the VPN ecosystem and defend users, right? So we built vPenalizer. So vPenalizer basically aimed to simplify investigation into the VPN through automation. And more importantly, being modular enough that when the new attacks against the VPN, new bad behavior by the VPN providers recognized, we can add a test to the vPenalizer and run it. And so it survived the test of the time, basically. And we acknowledge that at the beginning, very beginning, it's not a job of a university student or my lab to rerun vPenalizer constantly, because what are we going to do? Top 100 VPN? I don't know what people use in Africa right now on VPNs they use, or in Iran or in other places. So we had to facilitate investigation into the VPN to the grassroots movement or in local NGOs. Activists themselves, provide them with a tool that is actually easy to run and provide them insight. So that's exactly the goal of vPenalizer became. We hired a graphic designer to just make it actually nice app, because we learned that's actually really important for deployment and make it get easily be picked up by NGOs. More importantly, you can right now even yourself go to the vpenalizer.com/beta and download it. It's very, very easy, and it covers all the operating system. It's bootstrap itself. It asks the user to turn on a VPN. It tests 15 different things, and it asks you to turn off the VPN and does the same test over ISP, and then compare and show some results to the user, and ask user for a consent and upload the data to us. And the tests we do are network level tests, of course. For example, we test whether there's a DNS leak, IPv6 leak. They do best practices and so on. The paper vPenalizer was presented here last year, and some of the results here, I just want to highlight them. We downloaded 80 VPN providers applications and went through them. We found a very minimal of them support IPv6. Actually, the rest of them don't even tunnel. The IPv6 is completely leaked to the traffic. This was including our own university, so we reached out to them and fixed it. More importantly, we found they are horrible at dealing with tunnel failure. So if for any reason a tunnel fails, more than 33% of them, these are popular VPN providers, literally leak the traffic, the whole traffic. They keep the user connected to the internet and let the traffic to be leaked. We found even if you turn on all the features that the VPN provider asks you to turn on, like advanced feature, even in that scenario, they are not doing a good job in dealing with tunnel failure. And that's very sad, because causing tunnel failure in an adversarial network is not that hard. You just need to drop the packets for a couple of 60 seconds or so, and then basically you cause the user's VPN connection to be failed. We found so many of them are not communicating to user that for example, only browser traffic is being tunneled, and the rest is all the application are actually raw and leaked to the ISPs. We filed for disclosure. We have been talking to a couple of them that have engaged with us, like for example about the tunnel failure. They usually send the lawyers to the meeting with us, but and also the kindest, nicest human being in a call. So you cannot shout at them. One of them told us that most of our users are old people. If we inform them, warning, tunnel failed, your traffic is not going to be tunnel anymore, they move to the other VPN. So for that reason, we let the connection to go. I mean, how can I, and I couldn't, I didn't know he's serious, but it is actually, we looked into it further and he's serious. Anyway, so what's next? We are right now working with different NGOs so that they can do their own investigation in their own region and write reports. We have hit a lot of challenges here, especially for Iran, for example. It's not these threats, like leak of the traffic is not a problem of VPN provider. Like, it's not in a threat model of Iranian user at this time. They just want to be able to connect. They don't care about privacy, as you can, again, informally. This is my understanding. I haven't done the research to say that, but so imagine an NGO right now come up with a output saying that these are all the VPNs you're using and these are all leaking all the data. How we can actually, and not providing any solution. How can I fix that? So now I'm thinking of what's the next step there. You have vPenalizer and you can run it, but how can I provide a better option if all the VPN they are using is not good? And not freak them out because they basically cannot connect to internet with even the worst VPN at a time. Anyway, I'm sidetracking because, again, that's why I shouldn't work on Iran, because I don't stay. Oh, this doesn't go forward. To be honest, these are not sync. It's fine. Okay. But when we ran vPenalizer, we built vPenalizer, we started talking to people. They wanted to run a vPenalizer to build up their own reports. What we found out is there's so much things unknown and question unanswered when it comes to why people are using VPN, how they find VPN useful, where do they find VPN, how do they think the VPN is trustworthy, what they fear about, so on and so forth. At the same time, we have built a connection with VPN providers, and we had them on a contact base. And we had this opportunity to do a semi-constructed interview with them to ask them what are the dark patterns in your business. So we did exactly that. We built a qualitative survey to survey user and understand what is the user's mental model and consideration is when it comes to VPN. We also interviewed VPN provider who were okay to sit down with us for an hour to ask them about how do you make decisions when it comes to engineering, price, marketing, and can you tell us the dark patterns you see in your snake oil ecosystem? And that's the paper that is going to be presented in Music Security. This was also very surprised because when we launched our survey, we had more than 800 participants to a 20-minute survey without zero compensation. And from so many places. It was surprising, of course, because NGOs and Consumer Report actually advertise our survey. But to me, we really looked at the survey results to think, because we thought we were hacked or something, because in less than a day, we had more than 1,000 participants. We learned a lot from that user survey. For example, we learned 87% of users feel safe and very safe when using VPN. We found that 40% of them actually don't know what VPN provides them and have a flawed model of what VPN does. More importantly, we found this is actually shared among even expert users. So it didn't matter your technical knowledge. You think that the VPN will be doing the right thing. And we found most of the users, 60% and 50%, find their VPNs through search engine and recommendation website. When we talk to the VPN provider, the first thing we learn is that they say recommendation website like Top VPN or top10vpn.com's website. Those websites or influencers are all monetarily driven. So if you want to get to be named on the top of one of these popular websites, you have to pay them $50K a season. and they bid for it. And that was one of them shared with us, like not a small money. It's actually 50K for rank first, and it can go higher depending on what recommendation website you have. More important, another thing we learned is more than 50 or 60% of the users consider price and speed as the criteria they want more. And that's one of the reasons when you actually have, if you go to VPN provider website, you see a clock said the scan is happening, because they found that works. They say it expired tonight, but tomorrow go there again, you see it. Actually, we put this in our paper, how many times my students check to see whether the discount clock run out. Anyway, the biggest lessons we learned from this is we need to fix user education, because the VPN ecosystem is harder and long. We are long, far away from fixing it. So NGOs and CDTs and FTCs play a huge role in figuring out a way to communicate to user VPN is not a solution. And we need a better oversight on advertisement and marketing, and we really need to deal with that. For these reasons, we actually work with Consumer Reports to actually, because they are a consumer protection agency. And so for a year and a half, we worked with them, and the results of our collaboration was 3 extremely well done articles on the VPN. I urge you to read them or share them with your friends and family, because they basically did a dive deep into the ecosystem with us and went beyond what VPNalyzer could offer. We found out months after the reports were out that congressmen actually using these reports and the output of them to find a way to regulate VPN marketing. And I am talking with the aides of these people, these congressmen, to help them with providing them with the right data so they can make their case. I'm almost done, but the last thing I want to say is, whenever I start a problem, like, okay, let's look into the VPN, then we get stuck in it for years and become like this big project, a lot of output out of it. And the project I'm right now brainstorming and very, very fascinated, dedicated pursuing is splintering.net. Basically, if you're from embargoed country, you know what I'm talking about. It's not just a sensor messing with data. The server side often decide that you're not worthy of receiving equal content. So they either block you by saying this content is not available in your location, or basically reduce the quality of the content that you can get. And I have been working on this for years now, and we had a paper in 2018, which we downloaded a million of domain from different places, show how many of the websites actually server-side block. We recently, and you will read it in Usenext, we just did the same from 30 countries. We downloaded 8,000 apps at the similar exact time. And we look at the app and check what are the security and privacy offering of the same app in the 3 countries and how different it is. Like, is there an app that asks for more dangerous access in a region versus another? Is the GDPR actually causing the apps to do a better job in Europe versus the other? And that's the paper. It was a Herculean task because the measurement was really hard to do in 30 in the exact time. But that paper is coming up, and there are so much more that I talk to people who are maintaining infrastructure of the internet in IETFs, and I feel there are so many decisions are being made based on the network feature of a user, like where your traffic come from. And that's where we have to speak up now, where internet equity is being troubled by users' traffic and content being discriminated just because they're coming from a different country or a different region. So much more you'll see in 3-4 years from me on this. And we have been very lucky that, again, somehow Universe worked and our work picked up by a lot of journalists, and I was fortunate that I am more and more engaging now. I'm getting old. It's been a decade I'm in here, so people have been recognizing that I want to get into the policy and see how much I can contribute there. So I'm going to those areas now in the next 5 years, I guess. And with that, that's basically is my talk.
Cool talk. I think I read your paper on the Great Firewall many years ago. It kind of gets into my question. Maybe you do not have an answer for it. So historically, one of the things that was interesting about the Great Firewall in China is it's a censorship mechanism, but also a trade protection mechanism. Kind of in retrospect, you can see you don't have to do that gateway blocking if you have domestic companies, and the domestic companies have people who work there who censor it proactively, and you don't even have to do the network stuff. Have you seen any other examples, like similar to China, where there has been a strategic investment in domestic internet companies and domestic communication platforms in the same way? Because I'm not really familiar with how that goes in Iran or anything else, but just kind of wondering, like, is that, do everything you can in your borders where you can put some advice model?
There has been efforts. I mean, let me say that this is exactly, we have to investigate this. I don't know for so many countries, but I looked into Russia for the past, from 2016. I focused my research on Russia. Exactly. Why? Because I found that Russia's decentralized network, the fact that ISPs in Russia, not owned by the government, is much more representative of other countries' network than the China and Iran, which most of our investigation has been in our community. So when I look at the Russian, and especially in the past years, that's absolutely right. Russian government recognized that, well, when things doesn't work, even some of the certificate authorities might not issue certificates for the RU domain. That happened really in February last year. So some of the using the term non-certificate authority, no, that's not. I mean, they stopped issuing certificate for .ru, and that panicked Russia a lot because the military and there were so many of their local domains dependent on that. If the certificate was invalidated, so they ended up establishing their own local .ru domain. Local certificate authority for their own country, and then they force Yandex, which is the browser that Russian users use in its Russian language, and it's much more accustomed to the public there. They force them to accept that as a trusted certificate authority, certificate authority. And that means that government has now a complete control to end-to-end encryption. Because they basically have their control of the certificate authority, at the same time they have control of Yandex, and they have to, you know where I'm going. So I see a lot of these behaviors popping up. But for example, Iran decided to run their own social network. They have their own Uber, called Snap. In the demonstrations in the past 6 months, activists noticed that the government know exactly where they are, and they came arrested them, and they could connect that because they ordered food from Uber Eats, basically, of Iran. And they basically, the public in Iran started to ban any software that is being locally produced and not use them for this reason. All of this, there is evidence of that. Beyond that, I don't know.
Thanks for the nice talk and the great work that you are doing for many years.
My question is like this. At a high level, can you explain us like what's the difference between Russia's TSPU and Great Firewall of the China's JW, the middle boxes? And the follow-up question is like you yourself highlighted the active probing from China. Have you observed something of that sort from Russia yet? Or like what's your thought on that?
First of all, I didn't pay you to ask this question, but I will after, because that's very important. Look, when you look at the architecture of censorship implemented in China, it is on the choke point of the country. When the traffic gets out, the censorship is being applied and it's comes in. So, but in Russia, it was a different architecture because thousands of ISPs were operating, and the government at around 2012 or so started to restricting the internet. So they first gave the ISPs a domain list to block. So they said, here is your domain, block them. And then we wrote a study that showed from ISP to ISP how some of them actually do blocking on DNS, some applications, some not. So that really showed demanding the ISPs to do the blocking, even when there is a DPI, the filtering device that is $8,000, is not a good idea. So the next step they take is said, okay, how about we build their own commodity DPI? It's not that big a deal, and put it 2 hop away from a user. So the difference is here. Right now, this TS, we wrote a whole paper in IFC that we found thousands of these TSPU devices in the network around Russia, but it's so close to user, so and it's a black box. In our work, we work with local activists, so we know that Russian government told them to install these TSPU devices. They gave them a tutorial. It should be on upstream, thank you. In upstream, and it has to be implemented this way. And if anything goes wrong with it, you cannot fuzz it or anything. You have to send it back to us, and we give you a new one or fix it for you. But what it does mean is they have a root access right now in a decentralized implementation of their censorship policy. In a centralized way, decentralized implementation, 2 hop away from users. So right now, there is a region that does really have more activists in it. You can have a different block list for them. More importantly, you can do bigger surveillance because you're not dealing with a massive user traffic. You're dealing with like thousands of them, like a University of Michigan's type of traffic. And we work with the university's IT, and we're trying to write a paper exactly on this, that if you're only seeing thousands of people traffic, how much you can learn about the user. And that's basically what they do. And the other problem is it's a blueprint for other countries. Right now, you can hire Russians engineer and buy 100 of these DPI from them, get them to teach you how to do it, and you just do it in your country. It's so cheap to build a national firewall right now, which wasn't the case years ago. Everybody was told that, well, they have to build a great firewall in China. No, dude, you can have this simple setup in many countries.
Have you seen the active probing from Russia?
I haven't dig into it. I know that because we work with a lot of high-profile activists in Russia, and when, for example, Russia started throttling Twitter, we basically rallied a lot of people in Russia to help collect the data and so on and so forth. New York Times of Russia write about our work and said that independent body of work in the University of Michigan confirmed throttling is a means of censorship, things like that. So we found that our technique could not be used for finding these TSPU devices. So basically, they made it in a way that remote measurement was not being applied. What we did is, well, we found other side channels. So we found a very unique log in their caching, the way they were caching, and use that to be able to find the device. We did our investigation, but I feel like they are knowing about our work and trying to make it harder for us to investigate them. But just because we're working with very known activists there.
Thank you. We are very excited. Out of time, I have a super short question for you. So what I found also super impressive about your work is the actual impact that it has. I mean, like concrete mitigation strategy, you have broader barriers helping mitigate that. So could you tell us a bit more about it? I mean, how do you achieve that? I mean, we almost full of academics. I think we're all curious to know how we can achieve such an amazing impact.
I think it's hard to say. I don't want to say we were lucky because we put a lot of time. I remember at the beginning when no one knew about our lab, I had a knack for reading local news. So I knew about, for example, NTC Party, which is Russian blog. So we talked to stakeholders in the region. We really showed faith. We went authentic. Talk to validates, talk to lineage, talk to a lot of NGOs, and we were very persistent. So after a while, it became clear to them that we are not in the short run. We're not there to take advantage of their network to run the mission and move on. So that helps a lot because they basically trust you that you don't waste their time. Also, I think honestly, I think we did very right things in a critical time. For example, we put activists as an author of our paper, and I made it clear to them that my only request from them is just to read the paper and tell them whether they're proud of it, and if not, we trash it. So I give them authority. I work with them as I give them a respect that they earn, and not to look at the level of some NGOs. I really humbly remind them that they're better than me in every aspect of life. And so that helps, that kind of modesty in the beginning helped a lot for people to come to here. And I think some academics do practice that. And that's why I'm hearing from NGOs that they basically have their walls up for academic collaboration because they usually is a one-time thing and it's usually waste their time. Incentives should be aligned, respect should be there, credits should be shared. Be generous with all of this and get that.
Thank you very much for this coming talk and discussion. So thanks, Roya.